Now the square figure number is a little bit easier for people to figure out the explicit formula than the triangular. And if you notice in the pattern that in the sequence, you go 1, 1, 2, 4, 3, 9, 4, 16, you see that nice direct relationship between the sequence number and the number of dots. And what is recognized is that what I'm doing each time is I'm taking the sequence and squaring it. So I would say that the number of dots, f of n, is equal to the sequence number squared. Relatively an easier one for a lot of people to figure out. The recursive formula is a little bit harder. Now, if we're dealing with recursive, we know that we start off that the number of dots will equal the previous number of dots plus something. And we got to figure out, well, what is that something? So let's look at what is the change each time. Here I'm changing by 3. Here I'm changing by 5. Changing by 7. Changing by 9. So I'm trying to find some relationship to the new sequence number. So 2. Well, 2 plus 1 gave me 3. Could I use n plus 1? Well, if I check the next figure, figure 3. 3 plus 1 is 4, but my change was 5, so that didn't work. So let me try, what would happen if I doubled my sequence number? So 2 times 2 is 4, but I'm going from 1 to 4, so I gotta get down to 3. So how about 2n minus 1? So 4 minus 1 gave me a change of 3. Let's try the next one. If I doubled 3, that would be 6. 6 minus 1 would give me a change of 5. If I go to 4, 8 minus 1 would give me a change of 7. If I go to 5, 10 minus 1 would give me a change of 9. So what I'm going to be doing each time in my recursive is doubling my sequence number and subtracting 1 from that value.